Assalamu alaikum. Miss Rubina is here. Today we start the lectures that is based on titration. As we know that we have a different type of the titration, and including redox titration, precipitation titration, neutralization titration, and complexometric titration. And today we start the first type of the titration that is complexometric titration. Okay, for the explanation of the complexometric titration, I shared you PowerPoint presentation that I have taken it from NAT for ease of explanation. So first I want to share you this presentation. Okay. Okay, this is a complexometric titration. I found it on NAT. Now I start to explain it. First one, that is a complexometric titration. As such, we discussed that we have different type of the titration. So depending upon the nature of analyte we have for analysis, for the analysis of our analyte, or we have different type of the titration. We choose the type of the titration depending upon the nature of our analyte. If the main property of our analyte is that it is a oxidizing or reducing agent, or it is an oxidant or reductant, then we choose the precipitation titration. Similarly, if the molecule that have a more acidic or the basic property and the property of the neutralization or the property of ionization, then we switch to that of acid or simple acid base or neutralization titration. Or similarly, the nature of analyte or the substance to be analyzed has the property to form a precipitate, then we perform it with that of precipitation titration. When we perform this complexometric titration, when the analyte we have that is metal ions or any substance that have the property to form the complex, and not only the complex but it is a stable complex, then we perform the complexometric titration. यानी हमारे analyte के अंदर ये property हो कि वो complex बना ले, stable complex, then we choose हम कौन सा method choose करेंगे titration के अंदर, then we choose the complexometric titration. So the one thing is that our analyte is metal ions or any substance, any organic, inorganic substance that has the property to form the complexes. This is our analyte. Now we are going to perform, or we are going to study that is a complexometric titration. In the titration, we know that we can find out the unknown with the help of known. So the unknown we have that is metal ions, and known that is your titrant. And in this complexometric titration, we need your known, that is the titrant, and the titrant you have that is complexing agents, a substance that has an ability to form a stable complex with your analyte. So the two important things here we have that is our analyte, that is the metal ion, and the second thing that is your titrant. The titrant will be your complexing agent. So under the heading of this complexometric titration, we will cover what is our titrant, what is our what is our analyte, and the important thing that is included in titration, that is our indicator. The three important things that is analytes, titrants, indicator, and also the application of this complexometric titration. Now start with that of what is this complex or the complex formation requirement. First one, that is the complexometric titration. Under the heading, we will cover different headings. After that, what is complex. Basically, complex consists of a metal ion surrounded by the molecule or anions. Similarly here, the copper ion is surrounded by 3 or the 4 different ligands. This is the formation of the copper complex. And two important things are very important. One is the complexing agent, and the second thing that is the ligand or the metal ions. Now, the complex are the compound formed by the combination of the metal ions with the ligand. Basically, this whole theory that is based on a Lewis acid-based theory, as we know that according to the Lewis, what are the acids? That is depending upon the electron pair donors or electron pair acceptors. Okay, electron pair donors are the base and the electron pair acceptors are the acid. The whole theory that is based on Lewis acid base theory. Here the metal ion and electron deficient species, while a ligand is an electron rich and thus electron donating species. So mostly the ligand that gives the electron towards the metal ion, and they form the coordinate bonds and in the formation of a complex in the complex formation. When the ligand is a large organic molecule having 2 or more of the complexing group, like the EDTA, the ligand is called the chelating agent. Depending upon the ability of electron pair donation or depending upon the formation of bond coordinate covalent bond, if the ligands that has the property to share the single lone pair of electron or single pair of electron, then it is called the monodentate. Similarly, you have the didentate, tridentate, or bidentate, or if it has a more number of the electron pairs, then it is called the polydentate. When the ligand that has the property that it may bind from the different sides or have a different donating groups, then it is also called the chelating agent. Basically, this chelate, that's words that comes from that of a Latin words that is a crab-like structure, that it can form a complex with the number of the sides. Similarly, just like the that's a crab or catches are different things. So it is also called that sometimes we pronounce it as a chelating agent or the chelating agents. So if a monodentate ligand, multidentate ligand is there, then we call it as a chelate one, and it is the most stable one, because we know that when the bond formation from when a limited number of the bonds, then it is not stable as compared to that when a metal is supported or metal form a complex with a multiple sides, then it's form a very stable one. That is our requirement. So EDTA that gives fulfill all the requirements that we need to form a complex with that of a metal ions, because it is a multidentate one and forms a very stable complex with the metal ion. Here you have the different structures of monodentate, didentate ligands. And the metal ion act as a Lewis acid, as we discussed earlier, that is the electron acceptor, and the ligand is used as a titrant or the complex formation agent, which act as a Lewis base, electron pair donor, or a negatively charged group. That's some organic molecules that contains a negative charge. Okay. The metal ions हमने कहा that is a Lewis acid that can accept the electron pair, and ligands that can donate a number of electron pairs. Now, what is this complexometric titration after the complex formation? A complexometric titration is a technique of volumetric analysis in which a soluble, undissociated stoichiometric complex is formed during the addition of the titrant to the simple solution. Okay, simple in a sample solution. Complex formation किस वक्त होगी जब then we add a complexing agent to that of our analyte, and the complex formation must be sometimes it is a soluble and sometimes it is insoluble one. Mostly with EDTA we have a soluble complex is there. Undissociated stoichiometric complex is formed during the addition of titration. ठीक है, in complexometric titration, the formation of a color complex is used to indicate the end point of titration. Achha, one thing I also wants to clear that when you read this complexometric titration, you observe that most of the metal ion we wants to analyze it, or we wants to quantify it, mostly it's belong to a group of the metal ion that have a vacant F or D orbitals, and mostly we call them as a transition elements, and they have the ability when they form a complex, or they have the ability, they give the color complexes. So in complexometric titration, this is also important that these metal ion when form a complex, that it's also gives the colors, in forms the different colors, either when this metal ion combined with that of a titrant, or this metal ion combines with that of EDTA. ठीक है, metal ion sometime there is two important terms, that's metal ion gives the colors when it's form the complex with that of indicator. ठीक है, not with that of EDTA. It has an ability to form the complex with EDTA and also has the ability to form the complex with indicator. Complexometric titration are particularly useful for the determination of the mixture of metal ions in the solution. We can quantify the different metal ions present in the solution, and an indicator capable of producing a definite color change is usually used to. So all of these things that is required for the complexometric titration, a rapid reaction, a reaction between a simple reaction between a sample and the complexometric agents, complex titrant is required. Second one, that it must be some color changes there that gives you shows the completion of the reaction, and a suitable indicator is also required there to find out the end point of the reaction. Okay, now which complexation reaction can be used as a volumetric technique? The same thing one, that is the conditions required for that of a titration. Okay, so study karoge, that is simple one, the conditions required for that of titrations. This is a simple structure of EDTA. EDTA, why this EDTA? Mostly we used this EDTA as a complexing agent in complexometric titration. And when we observe the different procedure, we also observe that 99% of this complexometric titration is proceed with the help of this EDTA, because this EDTA, that is a very good titrant, and it is used to identify the number of the metals ions. This is the basic structure of this EDTA, ethylene diamine tetraacetic acid. As such, you observe that 4 carboxylic group is there. That's so it have the 4 hydrogen, or the replaceable hydrogen atom is present here. And the 2 nitrogen that also contains the lone pair, that is also present in the structure of EDTA. So it is an hexadentate. It can also donate the lone pair of electron that is present here, 1, 2, 3, 4, 5, and 6. So it is also called the hexadentate ligand. Commonly, EDT is represented in the acidic form as H4Y. H4, that is the, when 4 hydrogen is present, then it is called the H4Y. That is a simple structure of EDTA. EDTA is mostly in the literature. You found that instead of writing in the EDTA, that is H4Y, that is fully protonated EDTA. Fully protonated means 4 hydrogen is present with this EDTA. But EDTA, this EDTA solubility in water is very low. And in the lab, when we want to perform this or use to this EDTA for the estimation of different metal ions, this EDTA that is available in the salt form. How we convert this EDTA in the salt form? By reacting this ethylene diamine tetraacetic acid with sodium hydroxide, and that will replaces its 2 hydrogen with that of a sodium ions and converts into the metal salt, that is disodium EDTA, and the only 2 hydrogen that is present here in the structure, and it is represented as Na2H2Y2H2O. ठीक है, यानी कि सॉल्ट और वाटर फॉर्म हो रहा है जब EDTA रिएक्ट कर रहा है विद सोडियम हाइड्रोक्साइड एंड इट इज कन्वर्ज्ड इनटू सॉल्ट एंड वाटर एंड इट इज soluble in water. So this is also the important property of our titrant, that it is fairly soluble in water because we need a clear solution of titrant. So how we convert this EDTA into a soluble form by reacting with sodium hydroxide and converts into disodium EDTA. Now the different form of the EDTA, because this EDTA that have 4 pKa values. 4 pKa values means at the different pH, it releases the from hydrogen 1, 2, 3, and 4. Starting from that of a pH 2 to the pH 10, it's remove or releases all of its hydrogen 1. EDTA H4, the fully protonated form H4Y, that is present only in the major component, the very acidic solution, that is before pH. When we increases the pH, then it removes one by one its hydrogen, and at the pH 4, it is present totally in the deprotonated form, and the totally deprotonated form, it is represented as Y minus 4. Minus 4 means is all of these hydrogen that is removed from this EDTA. It is present in the full active form to form the complex one. So at the pH 10 or nearly at the pH 10 to 10.5, it form a very stable complex because all of these sites are available to form the complex with that of metal ions. Now, EDTA has 4 carboxylic groups and 2 amine groups. Like here is a metal ion, either it's a nickel, chromium, zinc, calcium. It forms this hexadentate and act as an hexadentate one and form a very stable complex, form a number of the cycle is present, rings is there. And one thing that is also very important, you also note it here, the single metal ion, they form a complex with this heavy structure. So it is a very stable one. Stability of the metal ligand, when depending upon the nature of the metal ion, depending upon its charge and the nature of the ligands, how much it chelates, and the basicity of the ligand, how much it donates its number of electron, size of the chelating ring, either 5 or 6 member chelating rings, number of the metal chelate rings is there. जितने ही greater number of the rings बनेंगे उतनी ही ज़्यादा stability होगी. Steric effect is also plays a very important role in formation of the role of the pH in EDTA titration, as we discussed earlier, that by increasing the pH, by increasing that pH, it have a very good effect and produces a very stable complex. So this is very important to maintain the pH during the EDTA titration. Why it is very important to maintain the pH because this EDTA, that is a non-selective one. By changing the pH, it will form the complex with the different metals ions. We discussed later. Advantage of the EDTA as a titrant, why we choose 99% of this procedure that is accomplished with that of a EDTA, because EDTA form a stable complex with the metal ion. That is one of the best important property that is required for the titration. Otherwise this complex is not stable, then the complex banega or break hoga, we can't quantify our analyte. The complexometry occurs in the single step, and is the titration of the metal produces a sharp change 1. Okay? And that is also a water soluble complex. One thing that is also you notify here, or that it may also form the insoluble complexes in water, insoluble. When it is the soluble in water, then it is called the sequestering agent. When the complexing agent form a water soluble complex, then it is called the sequestering agent. So EDTA, that is also called the sequestering agent because it is also form a complex that is water soluble one, and that is very important one, that is EDTA form 1:1 complex with all metals ions, and one EDTA combines with one metal ion, and this is stoichiometry that helpful in quantifying the analyte. because as we discussed earlier, the titer factor that is very important for the calculation of quantity of your analyte. If you know the stoichiometry of the reaction, you can easily mention that one EDTA react with one metal ion, and you can easily quantify the reaction. Irrespective of the charge of the metal ion, stoichiometry is same for all the metal ions. The reaction can be represented as metal ions, that is the number of the oxidation stage. And then it's converted into disodium EDTA. It is converted into no hydrogen is there. Metal will form the complex with that of EDTA. Then this 1:1 complex stoichiometry is 1:1. That is very important one for the calculation of our analyte. Now, after that, you have limitation of EDTA as such formation of insoluble hydroxides. As such, we know that metals are electropositive in nature. And when these metals, when present in water, and the pH that is towards a highly alkaline one, then there is a chance that metal will form a complex with or converts into metal hydroxides. And we know that this metal hydroxide complex, that is a very stable one. So metal is not available for EDTA at this high alkaline pH, and we know that EDTA titration is carried out under the alkaline pH, which may lead to the formation of insoluble hydroxide or basic salt that may compete with the complexation process. ठीक है. सो इसको थोड़ा सा हम यहाँ पर डिस्कस करते हैं कि many EDTA titration is carried out under alkaline pH. Alkaline pH that is nearly at pH 10 to 11. Or at this pH, metal has possibility that it form its insoluble hydroxide. So metal is not available to complex with titrant, that is EDTA. But how to overcome this one? Because we want to maintain the pH throughout the reaction, throughout the analysis, so we add the ammonia solution or the ammonia buffer in that in complexometric titration. And what is the function of this ammonia buffer? Ammonia buffer as such, it is the buffer. It also maintains the pH of the solution towards the alkaline one. And this ammonia that is also used as auxiliary agents. Ammonia that is also used as auxiliary agents. It's also masks the metal ions and covers the metal ions. Ammonia that's masks the metal ions and prevents the formation of hydroxides of metal. So to maintain the pH, mostly we use the amines or the ammonia buffer. So ammonia that plays a too important role here is it acts as a buffer to maintain the pH to form a stable complex with EDTA, and ammonia also provide a mask, a temporary mask of the metal ion, so avoid the formation of hydroxide of the metal hydroxide. So ammonia that is also used as an auxiliary agent to mask the metal ions and avoid the formation of hydroxide. So the metal is available to react with that of EDTA. To overcome this one, this is the limitation or that is mentioned here, and how to overcome it by adding the buffer one or a buffer that is a very selective one, that is the ammonia one. Otherwise we have also different auxiliary agents are also present there. There is a list of auxiliary agents that is also used to mask this metal ions to avoid this formation of this hydroxide ion at that alkaline pH. Lack of selectivity, since EDTA may form a stable complex with most of the metal ion. Its lax selectivity is used to estimate a single metal cation from a solution of the mixture of metal ions. Yes, this is second limitation, that's EDTA. At a single pH or at a different pH, it may form a complex with a different metal ion. For example, a solution that contains iron, a solution that contains a copper one or the calcium one, EDTA can at the same time may form the complex with that of this monodentate or the bidentate can complex one. But we can also reduce this, or we can make it's a very selective one by changing the pH. By changing the pH, it is stable, or it's make a stable complex with that of a different metal ions. As we know that at that alkaline pH, it only makes a very stable complex with that of a bidentate metal ions. Okay. And when you have a number of the bidentate metal ion, then we use the masking agent that masks our interfering metals ions, and then after performing the titrations with that of our required one, then we can demask it to also quantify the other interfering substances. So one thing, formation of insoluble hydroxide, how to overcome this lack of selectivity, that is also overcome with that of maintaining the pH of the solution, or using some masking agent. Absolute formation constant, that's EDTA, form 1:1 complex with all metal ions, and we need a very stable complex with one. So absolute formation constant, we can also find out the stability constant of the metal with that of ligands by using this formula. No need to memorize this conditional formation constant, leave it. Due to such important ones, also leave it this. Now the Metallochrome indicator, we discussed about the titrant, we have discussed about the different properties of EDTA, its advantages and disadvantages of EDTA, and how to overcome the disadvantages of EDTA, that is as a titrant. And we also discuss about our metal ions, that is our analyte. Now the third important thing that is called that is your indicator. In case of complexometric titration, the indicator that is also called the Metallochrome indicator. Now first we discuss with that of the indicator. Metallo, that is the metal. Yani ki indicator has an ability to form the complex with that of a metal ion and give some different colors. Give the different colors when indicator, it forms the complex with that of a metal ions, then it gives the different color. Metallochrome indicators are the organic compounds which are capable of forming intensely colored complex with EDTA. ये सेंटेंस जो है ना थोड़ा सा ये गलत लिखा हुआ है, ठीक है, इसको थोड़ा सा करेक्ट करेंगे आप अपने पास. Metallochrome indicators are the organic compounds which are capable of forming intensely colored complex with indicator with metal ions. कलर किस वक्त होगा, जबकि metals यानी कि metals किसके साथ रिएक्ट करेंगे, कॉम्प्लेक्स बनाएंगे इंडिकेटर के साथ, तो कलर चेंज होगा, नॉट विद दैट ऑफ EDTA. यहाँ गलत लिखा हुआ है, आप इसे करेक्ट करोगे, यहाँ पे आएगा मेटल आइंस. यानी कि मेटालोक्रोम इंडिकेटर्स आर द ऑर्गेनिक कंपाउंड व्हिच आर कैपेबल ऑफ फॉर्मिंग इंटेंसली कलर्ड कॉम्प्लेक्स विद मेटल. अच्छा, नेक्स्ट यहाँ पे इन्होंने फिर सही किया हुआ है, दिस मेटल इंडिकेटर कॉम्प्लेक्स, ये मेटल इंडिकेटर जो कॉम्प्लेक्स बनेगा इज अ वीकर देन दैट मेटल EDTA complex, and it has different colors than uncomplexed indicator. During the course of titration, the metal ions forms metal indicator complex is replaced from metal EDTA complex. It is not so complex one, it is very easiest one. When we use the word indicator, what it means, that indicator that is present in your reaction flask. When all the reaction between your titrant and analyte is completed, your whole of your titrant is completed, then the indicator react with your titrant. That is the common reaction or the common procedure in all the different type of titration. But in case of complexometric titration, there is the procedure is a totally different one. Here, the indicator will not react with titrant. Note this point. I also ask you in the exam that is the main difference of indicator that is used to finding the end point. In other type of the titration, as you already discussed in neutralization titration, when sodium hydroxide neutralizes the HCl or the HCl neutralizes the sodium hydroxide, the phenolphthalein that may change its color due to the change of pH, due to the hydrogen ion or due to the hydrogen or the hydroxyl ion of HCl or sodium hydroxide. ठीक है, जो नॉर्मल टाइट्रेशन है उसमें titrant की वजह से titrant react with your indicator and may form a change in color. बट इन इस कॉम्प्लेक्सोमेट्रिक टाइट्रेशन के अंदर एक चेंज क्या है कि आपका इंडिकेटर फर्स्ट कॉम्प्लेक्स बनाएगा मेटल के साथ, ठीक है। और होना क्या चाहिए नॉर्मल प्रैक्टिस के अंदर कि इंडिकेटर जो है वो एनालाइट के साथ कॉम्प्लेक्स ना बनाए, इंडिकेटर कलर चेंज करेगा ड्यू टू द टाइट्रेंट, और टाइट्रेंट क्या है, दैट इज EDTA. EDTA का रिएक्शन किसके साथ होना चाहिए? EDTA is a titrant, must react with analyte, that is your metal ion. So in this type of the reaction, when we add your indicator, it first form a metal indicator complex. In the alone, indicator has different color. For example, indicator we use the Metallochrome black T1. In the alone form, it is blue in color. When we add this indicator in your analyte, and the analyte is metal ion, depending upon the pH, it first forms the complex with metal ion. And the color of the reaction will change. Indicator, it have individual, in free form, it has a different color. And in combination with the metal ion, it have the different color. This metal indicator complex, that is a weaker one. इसकी स्टेबिलिटी कांस्टेंट जो होगी वो कम होगी, बिकॉज मेटल इज रिक्वायर्ड फॉर EDTA. We know that we add indicator in a very small amount, in the form of drops, and initially you have large number of analyte is there. When we compare the concentration of or the amount of indicator with that of analyte, so initially, or the amount of metal is more as compared to that of indicator. When we add the indicator, it forms the complex with that of a metal, and the free metal is also there. So when we start to adding the EDTA, that form the complex with the metal ion. When all of the metal ions that is consumed, free metal ion is consumed with that of EDTA, then the stability constant of, so the two type of the complex is present in the reaction flask. One is metal EDTA and the second is metal indicator complex. And the stability constant of metal EDTA is large as compared to that of metal indicator. So indicator releases the matter. अब metal वहां से जो होगा वो release होना शुरू हो जाएगा जब तमाम free metal ions completely complex बना लेंगे EDTA के. जब next EDTA, यानी कि when we add the EDTA, metal releases from that of indicator and form the complex with that of EDTA, and finally the indicator present in alone form. So the color will change. When all of the metal that is acquired by or make a complex with that of with EDTA, again the solution color will also be changed because no metal is available for the indicator to make the complex. The two important thing is that we can perform this direct titration when this metal indicator complex forms a very weaker one as compared to that of metal EDTA. During the course of titration, the metal ion forms, the metal is replaced. हमने कहा कि फिर उसके बाद replace हो जाएगा metal EDTA के complex के साथ. ठीक है, रिक्वायरमेंट ऑफ मेटल आयन इंडिकेटर कलर ऐसा चेंज हो कि देयर मस्ट बी सम कलर चेंज, मतलब दैट कैन बी इजीली आइडेंटिफाइड द रिएक्शन इज ओवर एंड द इंडिकेटर इज प्रेजेंट इन द वेरी इन अ लोन फॉर्म. ठीक है, the color reaction should be a very selective one and as a very stable one. अच्छा, one thing that is also very important here कि आपके पास जो मेटल इंडिकेटर कॉम्प्लेक्स इज अ वीकर वन एज कंपेयर टू दैट ऑफ मेटल EDTA कॉम्प्लेक्स, बट इट इज नॉट सच अ वीकर वन दैट इट इज नॉट अ स्टेबल वन कि आपके पास कलर बन रहा है और वापस से रिमूव हो रहा है, बिकॉज इट इज अ वेरी weaker one and it is not as such stable one for a certain period of a time before this metal is EDTA complex is completed. It must be a stable one, otherwise we don't have a sharp end point or a color change at the end point. So it must be at certain limit, it must be a stable one to provide you a difference in color. ठीक है, and this indicator that also required certain pH2 for the for its color change. So we also add some buffer solution to maintain the pH for the for the selectivity of EDTA or for that of metal indicator. Here first the metal, it forms the form complex with that of an indicator and it is a very weak one as compared to that of metal EDTA indicator. In the last indicator again will be present into the lone form, so it has a different color and in the lone form it has the different color and stability depend upon the pH of the reaction one. ठीक है, इसको थोड़ा सा पढ़िएगा. For a small the error km 10 to power 4 and the ratio of the conditional formal coefficient quotient of metal EDTA complex kmy to nh should be of order of 10 to power 4 to provide a good end point. ये हमने से पहले डिस्कस किया, that is the stability constant of metal. Example of metal indicator, yes, you have very important calmigate that we have different type of the complexometric indicators is available and mostly it is selective for different type of the metals ions, because here the color change is due to the complex formation between the metal ions and that of indicator. Mostly the most important indicator that we discussed here, that is Erichrome black tea. You must prepare one for your final exam. It is structure, it contains a disonium one nitrogen with that of a double bond one, is a two phenolic group is there that form the complex with the metal ion. यहाँ पे metal आके structure में जो है वो complex बनाएगा. With the removal of this two hydrogen bond, a metal will binds here to form a complex with that of this indicator. We already discussed that how the EDTA form a complex with the metal ion. Here that is how the indicator that form a complex with that of a metal ion. The metal will be there, two hydrogen will remove here, that will also change the pH of the solution. That is why we add the buffer of pH 10 or 11. Metal will form a complex with this two oxygen one in place here in the middle of this Erichrome and this muric side, that is also a very important one, and xylenol, that is also a very important indicator, but it's a very zyada ho jayega aapke liye. So you have to remember between the two indicator, that is the Erichrome black tea and the muric side one. Erichrome black tea that should have a different pK value 6.3 11.6 and mostly work on that of in between that is the blue color. We need a wine red coloration that is nearly to that of a pH 11. It shows the blue coloration. Indicator after losing a one hydrogen, a three hydrogen is there, one hydrogen is losing, then it's a red color, two hydrogen blue color, and -3 के साथ इसका color जो है वो orange one है. With the complex formation, it has a wine red color, wine red color. These are the different type of indicator. यहाँ उन्होंने mostly Erichrome black tea. You must know that its name, that is 1,1-hydroxy, that is this one, the hydroxy, naphthylene, azo, 6-nitro, and the 2-naphthol, 2 benzene ring when joined together, that is called the naphthalene ring, that naphthol, 4-sulfonic acid, and have a different acidic condition, it has a different pH values. EDTA जो है वो यूज करता है estimate this indicator को, and how much it's important thing is that how we make its solution, that is we use the triethanolamine along with that of alcohol to make its solution. You must remember how we prepared the solution of this. And second term जो मैंने आपको कहा, जो आपने याद रखना है, that is muric side, that is also used to estimate the calcium nickel indicator. और muric side, that is an aqueous solution. ये aqueous solution और freshly prepared किया जाता है. Xanilol को हमने skip कर दिया, इसे भी हमने skip कर दिया. Different type of titration हो सकती है इसके अंदर. Direct, as such, when the reaction is rapid, indicator is available. And one thing that is very important here, that indicator metal complex is not so stable, then we perform the direct titration. Back titration, when we perform the reaction is slow and the volatile substances is there. Or we can also perform this back titration when the reaction is a very slow one. Replacement, displacement, when suitable indicator is not available. When suitable indicator is not available, then we perform the displacement or replacement titration. That is also a type of back titration here. Why perform this one? When a suitable indicator is not available, then we perform this type of titration. Alkalimetric titration, depending upon the hydrogen ion concentration, because we know that throughout this reaction, hydrogen is releases from that of EDTA, or hydrogen is releases from that of your indicator. That can also be on the basis of hydrogen ion concentration. We can also quantify the analyte. Indirect titration, that is also a type of back titration. The only difference is there in case of indirect titration and the back titration we perform it here when the reaction is slow one, and the indirect, that is also a type of back titration, is a type of indirect titration. Indirect titration, when we have when the metal that form a very stable complex with that of metal ion, then we form this indirect type of titration. डायरेक्ट टाइट्रेशन आपके पास है सिंपल, आप जो टाइट्रेशन परफॉर्म करते हो उसी तरह से कि आपके पास मेटल आयन ईडीटीए के मेटल आयंस आपके पास है, दैट इज योर ईडीटीए आपका टाइट्रेंट है, दैट इज इंडिकेटेड इन फॉर्म ऑफ कॉम्प्लेक्स, दैट इज अ डायरेक्ट वन, एंड दैट कैन इजीली बी perform in the similar way. Back titration आपके पास है when the reaction is slow, mostly it is performed when we have a nickel one. Nickel, that is a very slow reaction with that of a metal one. And the third reagent, again here we use the metal one because we want to quantify the leftover volume of the EDTA, because we use an excess volume of the EDTA, so that's leftover volume can be quantified with the help of metal one, either in the form of zinc sulfate, magnesium or magnesium sulfate. EDTA, Erichrome black tea, that gives a very sharp color change with that of a magnesium, with that of magnesium, and so mostly EDTA, Erichrome black tea, that is used with that of this magnesium. Aluminum, cobalt, lead, magnesium, and mercury and the nickel can be determined by using the back titration method. ये वो molecules हैं जो कि back replacement depending upon the availability of indicator. If we use this one, इसे भी पढ़ेंगे. Alkalimetry, depending upon the hydrogen ion concentration throughout the reaction, we can also use this one. Indirect, this method determine the ions such as halide, phosphate, and phosphate that do not form complex with EDTA. Okay, ये indirect titration mostly हम इसलिए भी करते हैं क्या, जो directly form complex नहीं बना रहे. So in the determination of sulfate ion solution is treated with excess of a standard dilution of the barium ion, and then excess barium that is indicated with the help with that of EDTA, present filtration titration with EDTA. हम EDTA से उसका amount जो है वो मालूम कर लेंगे. और ये ऑलरेडी हम डिस्कस कर चुके हैं हाउ टू इंक्रीज द सिलेक्टिविटी ऑफ EDTA. केमिकल सेपरेशन मींस वी आर आइदर यूजिंग आयन एक्सचेंज रेजिन और certain chemicals that's remove the interfering substances. pH control हमने इससे पहले भी डिस्कस किया कि by controlling the pH we can also make the selective one for particular type of the metal ion. We can also use some masking agent or the unmasking agent or kinetic masking. One by one we can estimate the different type of the metal ions if it is present into the sample matrix one. ठीक है, by changing the pH that can also be यहाँ पे लिखा हुआ है. Calcium can be determined the presence of magnesium is strongly alkaline solution that is the pH 10. इसी तरह trivalent like bismuth and the ferrous can be selectively determined from the solution of the bivalent metal and strongly acidic one. By changing the pH, EDTA can be converted into the selective one. Masking by precipitation and masking by complex formation. हम masking agent हम इसमें use करते हैं. Mostly जो masking agent हमारे पास use होता है वो cyanides होता है for different type of the compounds के लिए. इन्होंने कौन सा use किया है भाई? cobalt separation के लिए insoluble filter है disodium EDTA के through, and also triglycerol is used as a masking agent. Copper by precipitating with the acid of solution containing copper and the zinc one. So the different chemicals are used. One, potassium cyanide. Yes, cyanide is used mostly for that as a masking agent. So potassium iodide, that is also used as a masking agent. Similarly, here you have the demasking agent. Mostly we use the formaldehyde that is used as a demasking agent. ठीक है, formaldehyde is used for the demasking agent. Kinetic masking, one by one आप इसको release कर दे present in the present. Application क्या है complexometric titration की? Complexometric titration have been employed with the success for the determination of various metal ions like calcium, magnesium, lead, zinc, aluminum, ferrous, manganese, chromium, etc. in different formulation. ठीक है, डिफरेंट फॉर्मुलेशन में हम जो इसे यूज कर सकते हैं, हार्डनेस ऑफ वाटर मालूम किया जा सकता है. दैट कैन आल्सो बी यूज्ड टू फाइंड आउट द फॉर्मेशन ऑफ hemoglobin on the basis of the concentration of ferrous iron 1. Determination of calcium in different formation. Calcium almost EDTA, then EDTA that form a stable complex with that of a calcium. Assay of that is not included in your that is your practical application. How we use this in titration curve, no need to that is enough one. So cover it through my lecture and through this lecture, and also I provide you the handout that is present in the reservoir state. Also make notes from from this lecture and also from the handout that is present on Raza photo state. ठीक है, or if you have any query regarding this lesson, please ask this question in the physical class, or you may also come in my office if you have any problem regarding this lecture. Not more than after Inshallah, I will post it today. Then you will ask questions before next Wednesday. ठीक है, next Wednesday पहले अगर आपको इसमें कोई problem है तो you can ask the question from me. Okay, Allah Hafiz. Thank you.